Good morning, Year 7, or maybe it's good afternoon. Um, Welcome to the first in a series of lessons that we're going to do slightly differently, and we're going to try and narrate some of the lessons that you would normally have had in school. So I hope you're all doing okay at home, not too bored, but hopefully we'll liven that up a little bit. So anyhow, your new topic for geography this half term is all about water. Okay, so it's called Water World. And we're going to start with a little task where I want you to see if you can work out what you think the connections are to water for each of the images coming up. So you will need to get yourself a pen and paper. Obviously, you can pause the video whenever you want, but see if you can have a go at these. Okay, so first one coming up. What could be the connection with water? Second one, it's a building, but it looks quite different to some of the buildings that we might have. What might be the connection with water there? There could well be lots of things, so geographers think like proper geographers. Next image, a rather tired, dirty looking teddy bear. Why is he there? What's happened? Next image, this is a gorge called Goredale Scar in the Yorkshire Dales. What connection has that got with water? Next one, I've got a truck that seems to be half submerged. What's the water connection there? Now we've got a student holding something called a ranging pole there. It's a piece of equipment that you might use in geography. In fact, year 7s, you might even get to use that later on this year. What on earth could be the connection with water? Okay, next image. I think it's pretty self-explanatory. This particular image has quite a good statistic there. Next one. You might have seen this image somewhere, possibly on television. This image on here, what might the people be pointing at?
What can I do for you?
Oh dear, that's Siri. And then a final image, which should be quite clear. Okay, let's run through some of the answers. You can self-mark these, see how well you did. Well, first one's obviously orange. Orange is about 70% water, so water's your connection there with the constituent of the orange. Then we've got a building built on stilts. As you can see in the bottom, if it was to flood, water could go underneath that building. So it's been built in an area, particularly because of the problems that it gets, the hazards that it has. So it's a building on stilts. Then we've got this poor teddy bear. Now it looks very much to me like it's been discarded, possibly because there's been a flood somewhere. You might be able to tell by all that brown material, that sediment that's been left behind by water. Then we've got this place called Goredale Scar in the Yorkshire Dales, which is a giant gorge. And that gorge has been carved out, as you can sort of see, by the water in the background, which has run through that valley and scoured it out over thousands of years. We've got a truck that's half sunk in water. Well, that's obviously some flooding that's taken place there, maybe a bit of quicksand that's occurred when a river's burst its banks, or when there's been a massive downpour, maybe a flash flood. So that's our connection with water there. Our next one, well, this girl is holding a piece of geographical equipment. It's called a ranging pole. Now, a ranging pole is used to sometimes measure angles, and we sometimes use them when we go down to rivers, which hopefully we'll be doing later on this year, year 7, to measure out the sort of the gradient of the stream and the angle of what's happening in that stream. So it's a ranging pole. This is Angel Falls. It's the world's highest waterfall. So obviously there's your water connection. Then we've got a very famous picture of a river. This is the River Thames in London. You'll have seen this if you ever watch EastEnders, because it's on the opening credits. But yeah, that's your water connection there. This one looks like some damage that's been caused by a flood. I don't suppose people can cross that bridge anymore. You can see to the left of the picture how high the water's been and where it's eroded away. It's worn away that bank. So flooding is probably the connection for this one. And then your final one. This is obviously a droplet of water, which you can have a million connections with water, but the one that I'm going to link it to is something called the water cycle, which is how our lesson starts today. So in today's lesson, we're going to be looking at the key terms in something called the water cycle, or as you go further up the school, you might use a posher word for it. They might call it the hydrological cycle. So as our challenge objective for today's lesson, we're going to see if we can describe how the water cycle works. But I would like the majority of you to leave our lesson today knowing how to explain the key terms in the water cycle, to know what they are, to be able to say, yeah, this one does this because, or this leads to, or this is so important. Okay, so my first little question for you is I want you to think for a couple of seconds how water potentially could get from the left-hand picture to the right-hand picture. So we've got a wave on the ocean through to a huge waterfall. In fact, that waterfall is the highest in England. It's called High Force Waterfall. So how might that water transfer from the left-hand picture to the right-hand picture? So at this point, I'd like you to pause the video, make a couple of notes, write down a number of things on your piece of paper. How could water get from the left-hand one to the right-hand one? And when we come back, we'll see if we can find out if you were correct or not. So pause the video at this point. Okay, year 7, welcome back. Some ideas then. Well, water in the left-hand picture might get to the right-hand picture because of this process known as the water cycle, the hydrological cycle. So water has somehow got from that wave to that river. Now the wave's in the sea, but the river is on land. So how might that water get there? Well, it will have got there via a process of evaporation, which is one part of a bigger cycle known as the water cycle. Now, the water cycle is something that happens naturally. And it has happened for millions upon millions of years. We've only got a certain amount of water in the world. Okay, there's no new water being created. So this means that water has to be recycled again and again and again. So every bit of water that you come into contact with, the water that you've drunk today, the water that you've had in your shower this morning, it's all been recycled. It's been used somewhere before. In fact, when you start to think about where it's been used before, it can blow your mind. The water might have been trapped in a glacier, in some ice somewhere. It might well have been on the top of a mountain. It could well have been out in the sea. But all the water that we use and that we come into contact with at some point has been used before. So I'm going to take you through the water cycle and explain some of the key terms, because that's our objective for today's lesson. We want to know and be able to describe the key terms in the water cycle. So the first one, I'm going to start at the top. And that's where we get all our water. Now, the posh word that we use for this is called precipitation. And it's one that quite often year 7s can't say very well. So have a go yourself. Precipitation. And precipitation means anything that falls from the sky. Now, that could be rain, it could be snow, it could be sleet, it could be hail. But it's anything in the form of moisture that comes from a cloud. So precipitation happens. What then occurs is that water can go one of a couple of ways. It might land directly into a stream, and in which case that stream or that river will take it on its journey all the way out towards the sea, where it starts to form part of that cycle. So that might be quite a quick journey for that that droplet of water. It might be that it hits the land and it forms what's called surface runoff. Now, sometimes you see water running off roads or surfaces, particularly if those surfaces are very hard, if they're what are called impermeable surfaces, which means that they don't let water in. And again, if that happens, the water can make its way quite quickly into streams and rivers and then down back to the sea and form that cycle again. However, not all water does that. Quite a lot of water infiltrates the soil. Now that means sinks into it. So as the water sinks into the soil, it makes its way down into the soil. It might make its way deeper underground, but every time it does that, it takes longer to form this cycle. So it's in storage for that much longer. The next term you might have is deep underground, which is called groundwater. So sometimes the water gets down into the rock, into what we call the aquifers, particularly if the rock is a permeable one. Permeable means it allows the water to sink in. And as it gets down into that water, it can form enormous stores. And some countries in the world rely on huge groundwater stores to provide water to their people. But over time, the groundwater can emerge, and it might emerge in a spring somewhere, which eventually then goes into a river, into the sea, and forms part of that cycle again. Now, sometimes on the way, water is intercepted, and that means it gets trapped by plants, by vegetation, and may never ever get into a stream and make its way down. At that point, it might well form a process or a key word called transpiration. The transpiration is when the water vapor evaporates and goes back into the sky again to form precipitation and to be part of that cycle. So transpiration might occur as well. And then for that water that does make its way down into rivers, into the sea, when it's heated by the sun, the process of evaporation occurs, which means that the water turns from a liquid into a gas. And as it turns into the gas, it rises, and eventually condensation starts to occur. And condensation is the reverse process when that water vapor, turns back into a liquid. And as it forms that, it creates clouds, which I'm just going to go back, creates your precipitation, and the whole cycle occurs again and again and again. And that process, that water cycle, occurs day in, day out, and has done for thousands, for millions of years. And it's the only way that we're able to use water. Now, for the next task, I want you to watch this video clip. Okay? If you've got your pen and paper, you might want to make some notes. You might want to watch it a couple of times. But we're looking out for the particular keywords that come with the water cycle. So listen out for some of those keywords that I've just talked through in the previous slide.
All the water on Earth today, every drop, is all the water there has ever been on the planet. Fresh water is actually millions of years old, the same water flowing in a continuous loop, falling as rain and snow from clouds to the Earth's surface, running in rivers, pooling in ponds, flowing from faucets, irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle. So simple, even small children understand the basics. Yet so complex, the most advanced Earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time, and yet we don't really understand it.
How to summarize what is known about the water cycle? With two words, flows and stores. The water cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere